Okay, this is gas laws part 2. I was running out of time, so I had to make 2 videos. So our next scientist is Gay-Lussac, Joseph Louis Gay-Lussac. So he was French as well. So Joseph Louis Gay-Lussac. So Gay-Lussac worked with some, of course, variables for gas. These variables are pressure and temperature. That means the constant had to be the volume. So in order to see this relationship between pressure and temperature of a gas, volume cannot be changing. It has to remain constant. Okay. This relationship is a direct relationship, just like Charles. So if one goes up, the other goes up. If one goes down, the other goes down. So if pressure of a gas goes up, the temperature is going to go down, is going to go up. If the pressure goes down, temperature is going to go down as well. It's a direct relationship. Our equation is going to be P1 over T1 is equal to P2 over T2. Of course, temperature has to be in Kelvin. So let's take a look at this. A gas container is initially at 47.0 millimeters of mercury. That's our pressure. And negative 196 degrees Celsius. What will the pressure be when the container warms up to room temperature of 25 degrees Celsius? So I'm going to plug everything in. P1 is 47.0 millimeters of mercury. T1, I got to convert this to Kelvin. So 273 plus a negative 196 is going to give me 77 Kelvin. It's kind of cold there. Is equal to P2 is what we're solving for. And our new temperature is 25 plus 273 is equal to 298 Kelvin. So I got to isolate P2. So I'm going to multiply by 298 Kelvin. Cancels out. What I do to one side of the equation, I have to do to the other side of the equation. So times 298 Kelvin. Kelvin cancels out. P2 is equal to, so 298 times 47 divided by 77 is going to give us a pressure of 100, I'm going to round it, 182 millimeters of mercury. So let's see if that makes sense. Gay-Lussac's law, it's a direct relationship. So if one goes up, the other goes up. So our temperature, or if one goes down, the other goes down. So our temperature increased. So our pressure should have increased, and it did. Our last, this isn't a law, but, well, it is a law. Combined gas law combines all 3 of those laws I just talked about. So the combined gas law is an equation that we can use that combines all of those laws. So it's going to combine Charles, Boyle's, and Gay-Lussac's. You can use this equation to solve for, like, here, I've got one thing. I'm given all the variables except for one. You can use this equation just to solve even a Charles law or a Boyle's law, and you just ignore the variables that are actually present. So our equation is P1 times V1 over T1 is equal to P2 times V2 over T2. Okay, there's kind of a lot of work here. I want to show my work because it is required. This is where your knowledge of algebra is definitely used. So it says use the combined gas law to solve for the final volume. So I'm going to plug everything in. P1 is 1.50 atmospheres times V1, which is 3.00 liters, all over T1. Again, I have to convert that to Kelvin. So that's 293 Kelvin is equal to P2 is 2.50 atmospheres times V2 is what we're solving for, all over T2, so 30 plus 273 is equal to 303 Kelvin. Okay, so I have to isolate V2. So first thing I'm going to do is I'm going to multiply 303 Kelvin. What I do to one side of the equation, I've got to do to the other. Kelvin. Now I've got to get rid of 2.50 atmospheres. So I'm going to divide by 2.50 ATM. What I do to one side of the equation, I've got to do to the other. 0.50. So Kelvin cancel out, atmospheres cancel out, and I'm left with volume units, which is liters. So V2 is equal to 303 times 1.50 times 3 divided by, I always like to put whatever's on the bottom. If there's more than one thing on the bottom, I always like to put it in parentheses. So I'm going to do open parentheses 2.50 times 293 close parentheses is equal to, my final volume is 1.86 liters. Okay, hopefully that will get you started on Unit 7. All of these problems, you are required to show your work, and I have given you an excellent example of showing your work. All of these have to be handwritten. You cannot type them in. You can either handwrite your problems and solve them on a piece of paper and take a picture and upload it, or you can do exactly what I did, and you can write directly on your screen with your stylus. Let me know if you guys have any questions. Have a great weekend.